Hi everyone, welcome back to my channel. Today our next topic in the unit of blood is bone marrow and hemopoiesis. This whole chapter and in the upcoming chapters are mainly going to be represented in a flow chart or a table manner, because I would love it if you actually represent your answers also in flow charts and tables, because they are like the key yielding marks for physiology. So without wasting any further time, let's dive into the chapter bone marrow and hemopoiesis. And before we begin, do like, share, subscribe. Okay, what are the concepts that we're going to learn? What is hemopoiesis? Sites of hemopoiesis, stages of hemopoiesis, steps of hemopoiesis, types and regulation. Okay, hold on. What am I going on about? What is this hemopoiesis? Well, simple. Hemopoiesis is the formation. That formation includes your development, growth, and differentiation. So development, maturation, and release of the blood cells. Hemopoiesis as a whole includes erythropoiesis, leukopoiesis, and thrombopoiesis. Erythropoiesis is the formation, maturation, and development of RBCs. Leukopoiesis is WBCs, thrombopoiesis is platelets, and they have to be constantly replaced so that new RBCs, WBCs, and platelets can take over. Now, the second concept that we will be learning about is the sites of hemopoiesis. Where exactly does the hemopoiesis take place? Remember, there are three places: liver, spleen, and bone marrow. After you're born, pretty much all of the hemopoiesis takes place in the bone marrow. Bone marrow is the major site. Now, it depends mainly on the stages where it occurs. First, in the yolk sac, liver, and the spleen. Yolk sac is pretty much when you're like within the womb. The stages of hemopoiesis, the location or the sites that we saw over here, that is yolk sac, liver, spleen, and bone marrow, is dependent on the stages of hemopoiesis. In the stages of hemopoiesis, there are three: mesoblastic stage, hepatic stage, and the medullary stage. The mesoblastic stage, as you can pretty much see, it is confined to the yolk sac. The hepatic stage will be confined pretty much to the liver and spleen, and the medullary stage, the medulla of the long bones, so it will be pretty much confined to the bone marrow. So the mesoblastic stage. The mesoblastic stage is the stage of development of blood cells in the yolk sac and non-yolk sac regions. So now you got to know that mesoblastic stage takes place in the yolk sac. But there are some sites which are known as the non-yolk sac regions where the mesoblastic stage does take place. The examples of that are like AGM and PSP, that is para-aortic splanchnopluric, splanchnoplura also, and AGM is aorta gonad mesonephros. These you will learn in depth about this in embryo under anat, like the mesonephros, which is related pretty much to the kidneys and like the development of those related structure. The splanchnoplura is like the layers, like there is somatopluric, splanchnopluric related to that. So this is about the mesoblastic stage. The next one is the hepatic stage. Now, during the second trimester of pregnancy, hemopoiesis takes place in the liver and spleen. In liver, hematopoiesis starts as early as the 5th week. I know this is pretty much of a memory based, but it would be lovely if you remember it. Even if you do not remember pretty much of it now, in the upcoming chapters you will end up remembering it. But right now I just want you to focus and finish it over here, so that in the upcoming chapters such concepts will not trouble you at all. So during the second trimester of pregnancy, hematopoiesis takes place in the liver and spleen, starting as early as the 5th week of gestation, and this hematopoiesis in the liver and spleen will reach its peak at the 5th month. Alright, so pretty much you can consider the graph to like go like this, reaches the peak. This peak region happens mainly at the 5th month. That is what you can just remember through this pictorial or the graphical representation. Okay, so in spleen, hematopoiesis occurs in the second trimester. So first it takes place in the liver, and as we approach towards the second trimester, it shifts itself into the spleen. Now, normally, hematopoiesis should not be occurring in your liver and spleen after you're born. But let's say that it still did occur. The sites other than the bone marrow, if hematopoiesis occurs, that is known as the extramedullary stage. Extramedullary, outside the medulla. So hematopoiesis does not occur in liver and spleen after the postnatal life, that is after birth. However, when the demand for the blood cells is more, let's say your body demands more blood cells, but the production of blood cells is less compared to the demand, then this extramedullary stage of hematopoiesis can definitely occur, which is quite abnormal. So then we have the medullary stage, that is the final stage, that obviously takes place in the bone marrow. So formation of blood cells in the bone marrow. Marrow cavities in the bone appear as early as 5th month of the fetal life. So you can consider or remember one number, fifth month of fetal life reaches its peak in, I'm talking about the hepatic stage, it reaches the peak during the 5th month, and in the medullary stage you see that the marrow cavities in the bone, which is responsible for the hematopoiesis, appears as early as 5th month of the fetal life. Now, erythropoiesis, that is formation of RBCs, erythropoiesis in the bone marrow occurs effectively towards the end of 3rd trimester of pregnancy and then continues throughout the life. So when the baby finally hits, hey, I'm in the 3rd trimester of pregnancy, so I am going to shift to bone marrow. My erythropoiesis will be shifting to the bone marrow and it will occur more effectively. Now this, what I was talking about here, extramedullary hemopoiesis after birth is abnormal. That is nothing but hemopoiesis in liver and spleen, and is physiological during intrauterine life. That is common that is before you're born. But however, hemopoiesis in these organs or in any other organ, that is extramedullary hemopoiesis after birth, is considered abnormal. After birth, if you find that hemopoiesis or hematopoiesis is occurring within liver and spleen, hey, you're abnormal. So extramedullary, liver and spleen, or any other organ. It could be any other organ too, not just restricted to liver and spleen. Now, this steps of hemopoiesis, you will learn this very beautifully in the upcoming chapters, that is erythropoiesis, leukopoiesis, etc. But then just know like the backbone of the backbone of those chapters, which are first stem cells, progenitor cells, intermediary cells, and mature cells. So stem cells, these give rise to the progenitor cells. Now progenitor cells are like the ones that give more of it. So the progenitor cells forms the precursor cells. The precursor cells are the ones that's responsible for forming the final matured one. For example, stem cells, progenitor cells, and precursor cell, let's say it is like normoblasts, all of them. And finally the matured cell over here will be your RBC. You will learn in depth of that in erythropoiesis. Now the stem cells in the bone marrow have two important properties. Now this thing that you see, the stem cells, we're talking about that, and we are saying that it has two important properties, that is self-renewal and differentiation. So these are the two important properties, because if they do not differentiate and if they do not renovate yourself, you're eventually going to go deficient. So they are of two types. The stem cells are of two types, myeloid and lymphoid. Lymphoid, as you can touch, related to leukocytes. Myeloid could be related to the erythrocytes, platelets, etc. You'll learn in depth later. Now the progenitor cells develop from the stem cells. That you already know, the progenitor cells over here, that they develop from the stem cells. The progenitor cells, what are they? If stem cells are myeloids and lymphoids, the progenitor cells are CFU-E. E is eosinophil. MEGA is megakaryocytes. Now eosinophil, the CFU, what is CFU? Colony forming units. Alright, so this colony forming units for eosinophil, megakaryocytes. You will learn all of this in detail. Do not know much, just know that stem cells have these two names if you see CFUs anywhere. CFUs is related to your progenitor cells. Now types of hemopoiesis. Hemopoiesis is broadly divided into three types. I've already told this to you at the beginning of the chapter, like erythropoiesis, formation of RBCs, leukopoiesis, formation of WBCs, thrombopoiesis, formation of platelets. I know it has been a little confusing, but trust me, do not panic. In the upcoming units, these are just like a foundation basis. So in the upcoming units, you're gonna get familiarized with these words. And I think we're back to being deep fried. Oof, another chapter done. Let's be happy and take a break, whatever. Anyways, all right then. Bye bye.